Good evening, everyone. Welcome to Sky Observers Hangout. And we're going to start our videos here in just a second. We are so glad we've got so many people here to join us this evening. My name is Michelle, and I am the Director of Public Observing at the Adler Planetarium. And joining me is Adriana. Hi, Adriana. How you doing?
I'm good. How are you doing, Michelle?
Pretty good, pretty good. And what do you do at the Adler Planetarium?
I am an astronomy educator.
Fantastic. Well, I'm so glad to have everybody here. And Sky Observers Hangout is for you guys, but we have even more people behind the scenes. Adriana, do you want to tell these folks who we have behind the scenes helping us out?
I would love to. So we have two friends helping us out today. We have our YouTube chat moderator, Sarah. Hi, Sarah. And also in the chat is our astronomer friend, Lucienne. Hello, Lucienne. So if you see a name with a blue wrench next to it in the chat, that's Lucienne helping us by answering your questions and your comments.
Fantastic. Thank you, everyone, for joining us again. Sky Observers Hangout is our show, and it's a place for us to gather together once every couple weeks to absolutely nerd out about the sky. And our goal is to give you practical tips and things to look for in the sky we all share. And if you just want to watch, that's perfectly fine. But we would love to see you interact with us in the chat. We want to see your questions. We want to see your observations. So go ahead and say hi in the chat.
Yeah, talk to us. So to get the chat rolling, tell us where you guys are tuning in from. Let us know in the chat.
Yeah, we're going to highlight a few of you in just a minute. So while the Adler's doors must remain closed, and if you're not familiar with us, if this is your first time, we're from the Adler Planetarium in Chicago. We are closed to the public, but we are concentrating on our online programs, and we're doing our best to keep our virtual doors open by creating and sharing some absolutely out of this world content for you. If you wouldn't mind, there's going to be a link that will appear in the chat in just a sec, and you can pay what you feel is comfortable to contribute to our programming to keep programs like Sky Observers Hangout going. Thank you so much for allowing us to share our universe with you.
And you can help us get more visibility for our shows by just hitting the subscribe button for the Adler Planetarium's YouTube channel. If you like us, you can also give us a thumbs up on this video. So I'm excited to see all of these folks hanging out with us tonight. We've got people from Elgin, from Skokie. Oh, I love Skokie. Skokie's nice. From downtown Chicago, from Florida.
Oh, welcome,
quite a ways
Florida.
away. Yeah, and Wisconsin. That's exciting. It's nice to see so many people here tonight.
Cool. Well, keep putting it in the chat. Keep telling each other where you're from, and we'll say hi some more throughout the program. And we're going to keep an eye out for your questions as well. So Lucienne is going to answer some of those questions, and there might be some that we might answer during the program too. And I know at least one of them that we're going to answer in just a few minutes. But if you are watching this show live, and so we're doing it tonight, October 13th, 2020. If you are in the central time zone in the United States or anywhere east of there right now, and it is dark out where you are, Mars should be visible for you. So this is all about Mars. We're going to point out where and how you can find Mars. In the central and eastern time zones, it is in the eastern sky right now. Look for, if you want to go outside, if you're on a phone, you can take us with you. Go outside, look for a really bright orange thing low in the eastern sky. Let us know if you are outside right now. Put it in the chat if you can see Mars. If you're watching it after we present it live, Mars will be visible after sunset, and it will be especially bright for the rest of October. So let's take a look at how we can find Mars. We are going to share a program called Stellarium. It's a website, and when I share the window, you'll see the web address that comes up, but Stellarium is completely free. If you watched the show last week, you saw Stellarium being used. And so this is Stellarium. And Adriana, keep an eye out. Make sure that I am actually showing Stellarium and not some like random email or something like that.
Nope,
so
I'm seeing
I've
it.
got, you got it?
Yeah.
It's always great when the technology works, right? So I've got Stellarium set for basically right now. So right now it is almost 8:05, and I have it for 20:05. So if you take a look in the lower right-hand corner, it says 20:05. It's a 24-hour clock. So to get the time in a non-24-hour clock, subtract 12 and add PM. So 8 p.m., 8:05 p.m. And we're facing east, and basically a little bit above the horizon, we've got an orange thing. So if I click on Mars, so I just did a left click on Mars, I can see that its altitude right now is 18 degrees above the horizon. To find 18 degrees above the horizon, stick your fist out. The bottom of your fist is on the horizon. The top of your fist held out at arm's length is 10 degrees. And if you want to get about 20 degrees above the horizon, you just start stacking fists on top of that. So 2 fists stacked on top of each other is 20 degrees. And that is about how high Mars is. So I'm hoping some of you are outside seeing Mars right now. But we want to show what else Stellarium can do. By the way, I have this set for where I am, so you can tell Stellarium to get your location. So it'll show you your sky, and I can turn some constellations on. There we go. And right now, so people have been asking us, so how do I know if I'm looking at Mars? Well, it's kind of the only really bright thing that's over in that direction right now. So if you think you're seeing something orange, you got it. You can't miss it. But in the sky also to the south, so if you're facing east, go 90 degrees to your right, and you will see a little higher up in the sky, a little bit toward the southwest. I'm going to zoom in a little bit. You can see Jupiter is the brighter object, and Saturn is a little bit to its left. And kind of, again, these are the 2 brightest things in the sky, along with Mars, the 3 brightest things. So they happen to be planets. If you're wondering if you're looking at a star or a planet, you're probably looking at a planet, because these are rather bright. But we can go all around the sky if we wanted to see what else is up there. We're not going to focus too much. Sorry, focus, astronomy pun. Sorry, they're all terrible. Yeah, they're not funny. So we are not focusing on the rest of the constellations and stuff. We're just talking about planets tonight, especially Mars. But I wanted to show you all this so that you can use Stellarium yourself and go out and try to find some of this stuff. One thing that I didn't show last week, that you can turn this into night mode, meaning if you take this outside and you don't want to mess up your night vision, turn on night mode. It will turn your whole screen red, and that won't mess up your night vision. And when you come back in, just click that button again, and I'll turn it back to regular normal colors. Pretty fantastic. So anyway, that is where Mars is for tonight. And to learn even more about observing Mars, you can check out our Sky Observers Hangout show from last week. It was from October 6th. And to learn about how planets look in the night sky as well as Mars, be sure to watch the September 30th and October 7th issues of Adler's own Skywatch Weekly with our pal Nick. He does a great job. And you can find Skywatch Weekly on this same Adler Planetarium YouTube channel. Adriana, anything else that I missed? Any questions about Stellarium or what's in the sky before we move on? How are we doing?
Well, I just wanted to mention that, speaking of friends that we have that are joining us in teaching you cool stuff and joining us in doing some observing, we've got some members of the Naperville Astronomical Association here tonight with us. They're going to help us get an up-close view of Mars through their telescopes, and they'll be with us in just a few minutes.
Yep, we're going to join them in just a bit. Oh, I know there was one question. There is a fan out there of Sky Observers Hangout. Name is Louie. Louie, you wanted to know if the moon is close to Mars tonight. The answer is no. So the moon it's almost new moon, meaning the moon is almost in the same direction in the sky as the sun. If you get up right before sunrise, you'll see a teeny tiny little moon crescent tomorrow morning if it's clear. But it is nowhere near Mars tonight. So there you go. Louie, that was for you. That is where the moon is in the morning sky, and Mars is in the early evening sky right now, and it'll be up all night long. So, all right, I'm going to stop sharing. Anything else, Adriana, before I move on? We good?
Yeah, I think we're good for now.
Awesome. Okay. So tonight is a special night. All right. So Mars is at opposition. You may have heard this term. It's some stories about Mars. The media might have used it. Mars is opposite the sun in the sky. As the sun goes down, Mars rises. Right. That's what opposition means. And so I'm going to tell us a little bit about, or both of us are going to tell us a little bit about what this actually means. Why is this significant at all? So let me share my screen again. Give me just a sec. There we go. All right, so this is a view as if you are looking down on Earth from above. So we've got Mars on one side of us and the sun is on the other side. Again, sun goes down, Mars comes up, and Mars is literally up all night long on the day of opposition. One thing to remember, this drawing very much not to scale. So don't do any mathematical calculations from this map. This is not the point. Just wanted to show you what that word opposition actually means.
Great. And Mars at opposition isn't just interesting to look at in the sky, though I do love looking at it in the sky because it makes Mars look super bright. But around the time of opposition is also when NASA and other space agencies choose to send spacecraft to Mars. As we're doing this show in October 2020, there are 3 spacecraft on their way to Mars right now, and they'll join half a dozen spacecraft already in Mars orbit. So it's basically a party out there.
Yep. Just stop and think about that for just a second. As we are doing this show, there are 3 spacecraft on their way to Mars. You got to admit, that's cool. That is something to really marvel at. I want to tell you just a little bit about some of those. The Mars orbiter Hope from the United Arab Emirates launched on July 19th of 2020. Its goal is to study the atmosphere and climate of Mars, and this is the mission patch from that spacecraft. So yay, United Arab Emirates, sending your first Mars craft. Hope it gets there and does a lot of cool stuff. China launched the Mars mission called Tianwen, and I probably just spoke that very incorrectly. I apologize. I practiced. I don't know how well I did, but I practiced. I hope that's okay. And that launched on July 23rd of 2020, and that mission is pretty hefty. It includes an orbiter, a lander, and a rover. And that's the first time that sort of combination of spacecraft has been attempted on Mars. There have been orbiters and landers, there have been landers and rovers, but there haven't been orbiters and landers and rovers. Well, in this case, one of each of those. So again, good luck to China. Hope everything goes well with that mission too. The United States, our third one, is the Perseverance rover. And if you're thinking to yourself, wait, haven't I seen this before? This is almost a twin of the Curiosity rover that landed in 2012, but different science instruments. Perseverance is scheduled to land in the, what's that?
Fraternal twins.
Fraternal twins. Yes, you are right. Yes. See, astronomy humor, not great, but Adriana's the queen of it. So this spacecraft, this car-sized rover, about 2,000 pounds, is supposed to land on Mars on Thursday, February 18th, 2021 at around 2 o'clock in the afternoon. I don't remember the exact time, but that's pretty close. So Perseverance is going to look for signs of past life on Mars. How cool is that? And collect and package up rock samples for a possible return to Earth on a future mission that hasn't been designed yet, but they're going to get some rocks all ready to go.
Very cool. We do have some questions that I wanted to ask.
Sure, go for it.
What's the, John asks, so what's the travel time to Mars for these 3 missions on the way?
Yeah, so the missions launched basically all in July, and they're going to arrive in early to mid-February. So whatever that time is, so August, September, October, November, December, January, February, about 7 months. So yeah, it's about a 7-month travel time to be able to get there. So great question.
Got it. Cool. And I've got a question for you. Why did all these missions launch at about the same time? Can't we just go to Mars whenever?
Well, you got to admit, sending spacecraft to another planet really is, wait for it, rocket science, right? So the key, I know. The key is to use as little fuel as possible. So I guess technically, yeah, you could send a spacecraft anytime you want, but why would you? Because more fuel equals more money equals bigger rocket equals heavier equals more money. And so to make the trip as short as possible, NASA and other space agencies launch around the time of opposition. So a little before opposition, they launch, and they arrive a little after opposition. And so they want to launch when Earth and Mars are closest together, and when the two planets are on the same side as the sun. So this is something that is important to do. All right, so let's see what this looks like.
Ooh. All right. So launch happens a little bit before opposition. Yeah. What you want to do is launch the spacecraft to follow a curved path so that Mars is there when the spacecraft arrives. The two planets' orbits are about 50 million miles apart, but the total amount of mileage the spacecraft travel will be about 200 million miles along that curved path. So we can put it another way. Michelle's going to show us an animation here. And for drama, launching from Earth and landing in a very specific spot on Mars is like hitting a golf ball from Los Angeles and hitting a hole-in-one at St. Andrews Golf Course in Scotland.
Let's make sure that this really sinks in, because when you launch the spacecraft, the planet is not where you need it to be. You are timing it exactly so those two come to each other at the same exact time. If you're a little bit off, you're going to miss the planet, or you might crash right into it, one of the two. So
both bad.
Yeah, both bad. Yeah, exactly. But there's an easy activity that you can do to try to illustrate this, and I'm going to demonstrate this. So I'm going to stop sharing my screen. So give me a sec. There we go. All right. So I have a setup. All right. And here is the way this works. First, we have a lot of little balls. I've got some of our cat toys. So I'm hoping by doing this, I'm not going to be attracting the cats. They're around here somewhere. So we'll see if they make an appearance. Then I'm going to get up for a second so you can see this. I have a spinning chair.
Very technical stuff here, Michelle.
Very technical. There's a lot of people working from home. You probably have a spinning chair at home, or you can go find a merry-go-round on the playground or something like that, right? Then I have I have a chair here so you can actually see it. You don't have to put your target onto a chair, but I want you to be able to see it on the camera. And then I have you can use a bucket. I've got a dish, whatever that you have to be able to get this to work. And so here is how you can try to launch your own Mars spacecraft. Don't you like? It's orange. Isn't it great? So you can launch your own, I know, I planned it. You can launch your own Mars spacecraft from the spinning Earth to Mars. All right. Now I'll demonstrate in a second. Now we aren't making this exactly right because this thing needs to be moving. So it isn't quite right, but bear with me. I'll show you, I'll demonstrate. Here we go. I'm going to position myself here. I'm going to spin in a counterclockwise direction, and I'm going to spin around, and I'm going to try to launch my spacecraft. I didn't make it. Let me try it again.
No.
All right, I've got another cat toy. All right, and I'm going to try to make it, and I missed. See, it really is rocket science. Now you can try this again. If you don't have a spinning chair, you can try this on a merry-go-round out in the playground. Just get a bucket or something, a small one preferably, and run the merry-go-round, run it around, and try to launch your spacecraft toward your bucket. You can make this a little harder. Give your bucket to someone to actually move in a Mars orbit. You can try it that way. Or if you're at home, maybe you've got a robot vacuum cleaner. Maybe you want to put your bucket on top of your robot vacuum cleaner. If anyone does this, the merry-go-round version, the spinning chair version, the robot vacuum cleaner version, we want your videos. We want to see this. You don't have to do it tonight, but we seriously want to see this. So if you happen to take pictures or you take a video, share it with us. Go to any of our social media feeds, use the hashtag #lookup. We may show your video at a future Sky Observers Hangout program. If you really do a video on this, trust me, we will show it. So there we go. We would love to see all that.
We've got comments from Steve and John saying, perhaps a carefully calibrated beer will improve Michelle's aim. Or add a martini while you're trying this. These are okay suggestions.
These are interesting suggestions. The only thing I have is sparkling water right now, so my aim is not great. However, it does show you even my simple demo version, I didn't get it inside the container. Think of then sending a car-sized spacecraft 200 million miles to land in a very specific spot on Mars. It really starts to illustrate how difficult this is for the Hope spacecraft, the spacecraft, the lander rover orbiter from China, and the Perseverance spacecraft. So it's all difficult, and they make it look so easy. So anyway, again, you take pictures, you do this video, do this demo, hashtag it, look up, and we want to see it. Okay. While you are going out to observe Mars, if you have gone out to actually do this, that's awesome. We want to know if you're seeing Mars, but we have a special opportunity. All over the world, there are clubs and groups of people who love astronomy and they want to meet and talk about it. In the Chicago area, we have quite a few clubs, and we count them all as friends of the Adler Planetarium. And joining us, you'll start to slowly see their videos come on. So I'm giving them the verbal cue. There they go. They're starting to join us. You'll see them. These are all friends from the Naperville Astronomical Association that is headquartered in Naperville, Illinois. So there we go. Hi, guys.
Good evening, Michelle.
Good evening. So, and Adriana, would you like to introduce our first member of the Naperville Astronomical Association?
So first, joining us from the Naperville Astronomical Association, this announcer voice is what's happening, I guess, their own observatory, joining us from their own observatory is Drew Carhart.
Hi, Drew.
Welcome, Drew.
And we are also joined by Commander Frank Klickar, also a member of the Naperville Astronomical Association, and he has also offered to show live images from his own observatory and telescope in the western suburbs. Hi, Frank.
Welcome aboard to Megamark Observatory.
Thanks for joining us.
Thanks for joining us to both of you. And so we're going to start with Drew because he's got the planet of the evening through the telescope there. So Drew, would you like to show these folks a bit of the red planet and tell us a bit about the Naperville Astronomical Association and your telescope? Did it cloud up?
Do we have a cloud there?
Yeah.
We have a cloud. Let me see if I can still find it through the cloud. Your timing is excellent.
Oh,
there we go.
There we go.
There it is.
So the cloud is dimming it, but let me center it a little bit here. I can just turn the camera up. That's the nice thing about the planets is, at least the planets you see with the unaided eye, like Mars or Jupiter, they're bright enough that they kind of plow through the clouds a little bit.
Right. So Drew, the image is kind of swimming around a little bit.
Let me see if I can get the exposure is good.
Yeah. So what's going on?
Anyone who has been outside on a hot summer day and looked over, especially like a hot road, you see heat waves rising, and they blur the light. It looks shimmery to you, and that is going on all the time in our atmosphere. There's always warm air rising and cool air sinking, and they're mixing and blending together. That turbulence in the air actually bends the light coming through. That's what makes stars twinkle at night when you go out. The starlight, if you were just above our atmosphere, only a couple miles up, you would see stars as perfectly steady. The stars don't twinkle, but down here on Earth, when we look up and see them, oftentimes you see them twinkling, and that's this exact effect. Astronomers call that turbulence, that blurring of the light, we call it the seeing. And so some nights the seeing can be pretty good around here, where the images will be a little sharper and more stable. And some nights, like tonight, the seeing is pretty bad. We had all the winds today, and the past couple of days actually, and we had a cold front go through, and that all really stirs things up, and you get a lot of turbulence like this. We're also looking at Mars down low in the sky. I don't know if I'm appearing up I know it's not very bright in here, but if you can see me by the telescope up in the corner of the screen or whatever, the telescope here is pointed down low because Mars is down low in the sky. And when we look straight up, the Earth's atmosphere, I should say Earth's, don't call it the Earth. Earth's atmosphere is actually fairly shallow. If you had a globe like you normally would have in your house or a classroom, the real atmosphere that we can breathe is only about as thick as a couple sheets of paper on that globe. It's not thick at all. So when we look straight up through it, we're not looking through a lot of air. But when we look toward the horizon, we're looking across through a lot more air. That's why the sun turns red at sunset, or the moon looks red or orange when it's rising or setting. It's because you're looking through so much more air. And so if there's turbulence in the air, like there is tonight, it'll be all the worse when we're looking down low in the sky. So here we have Mars looking like a little dancing amoeba or dot or whatever there. The reality is, when we take our telescopes, and I'm going to turn the exposure down a little bit because the cloud has kind of gone past. Oops, I'll get my hand off the screen. The amount of turbulence we'll see varies, but it's something we put up with as observers. We also would, if I was going to go out tonight with my telescope to specifically look at Mars, as long as the sky allowed it, the clouds allowed it, I'd rather go out at midnight or 1 in the morning tonight when Mars is up higher, and again, I'm looking through a lot less air than now. But it's evening, and this is live, and we wanted to share it with you anyway.
So Drew, some folks are probably noticing that, well, maybe there's a little bit of shading on the planet. Is that real, or is that an artifact of your camera?
Okay. Yeah. First off, I will note right now it's getting dimmer. That's a cloud. So, the video camera is really, the video camera doesn't adjust like our eyes do. Our eyes can adjust amazingly well to wide brightnesses of changes in brightness, and also see subtle differences in brightness, whereas it's a little cruder for the video camera. But that marking on the planet is real. So you've got the disk of Mars here. There's a grayish kind of patch that moves across it this way here. If I was observing this through my eye, with my eye through the telescope without a camera, I would see this a little bit more sharply. But the main thing is I would stare at it just steadily. And there'll be moments, even when the air is turbulent like this, there'll be moments when just for a moment, it'll get sharper and clearer. And my eye can pick that up again better than the video camera can, because my eye has better resolution. But you just watch, you keep on watching until you see little details like that and build them up. There's also, I think I've got it rotated, so it's just about at the top, a little white spot it's actually the southern polar cap, the ice cap, but it's just about hidden in the turbulence tonight. But yeah, so this is a real color view. There's no filters in this camera. It's adjusted to respond like it would in the daytime it's just basically a closed circuit TV camera. So this is the color, this is pretty much exactly like it would look color-wise through a telescope to your eye. You go out in the sky and look at it now, you'll notice that Mars is not the red planet, as it's always called. It doesn't look like a stoplight. It looks this rusty peachy color. So, and this is the real color of Mars here.
Great.
That's
Can I
really
ask
cool.
you a question, Drew, from a guest?
Sure.
So Karen asks, how much magnification do you need to get Mars to look this big?
Well, it's a little bit confusing to talk about when we're doing video work, because then you've got the question of how big is your screen and how close are you sitting to your screen? So
that's a good point.
This is relative to how Mars would look now at, I would say, maybe around 150 times magnification, maybe a little less than that, maybe 120 to 150 times that. If you're looking at this on your phone and it's only a 3-inch screen, then you're only at about 60 magnification, because it just got a lot smaller. And if you have a 3 foot across monitor and it's filling it up, well, you're seeing it a lot bigger than I am. But in reality, for the amount of details you're seeing, you're at maybe 120 to 150 power. The planets are actually the smaller things we look at in the sky, and that may sound surprising because we look at galaxies and things that are farther away, but to see the detail on planets, you actually need to use some magnification, whereas we do a lot of observing, even with a big telescope. This is our 16-inch telescope in our main observatory here. We often use this at around 60 or 70 times magnification, because that number, now you can see the dark stripe that interrupted myself there, as
Yeah,
it's
sure
getting
can.
dim here. As the cloud is playing with it here. But anyway, we oftentimes use what sounds like lower magnifications, even with a big telescope, because a lot of the things we observe are not very tiny. And they'll look brighter, less magnified. So the number of...
Oh, I think we've temporarily lost Drew's audio. I'm going to talk until he can. We're going to keep showing his video.
I can
What
get
he's
some
doing,
questions from here, Michelle.
yeah. What's that?
telescope is not what we talk about at all. We talk about
Oh,
their
there we go.
light gathering. I think I
There
lost
we go.
Michelle.
Nope, we got it.
Okay.
Great.
That's okay.
Anyway, I don't know if that answered the question, but
Oh,
Sure
it does.
did.
Thank you.
Yeah.
We've also got a question from Aaron. I don't know who wants to take this, but anybody is welcome. How well do the agencies coordinate when they're sending out spacecraft so they don't disrupt one another's missions?
That's a great question. Lucy
I
Ann may be
know.
able to provide a little bit of clarity on this. To my understanding, there really isn't a lot. I don't think there's any, as a matter of fact. But ooh, Mars looks good. Sorry, I'm getting distracted by the view. I don't think there's that much coordination between the space agencies, but you got to admit, Mars, even though we say it's a small planet, it's half the size of Earth, that's still pretty big. There's a lot of room there. And usually if you're going to send something to land on the planet, you're going to know at least a narrowed down group of sites where your spacecraft is going to end up. So it is highly unlikely that anything would disrupt anything else. Space is big, space is far apart, and the spacecraft are far apart. Even though we say there's 6 spacecraft there, there's several more on the way. There's plenty of room for everything there. So that's a really good question. All right. Any
Great.
other questions? Drew, it's looking pretty good. I'd say I'm seeing the dark shading even a little more easily as the cloud, I think, goes past Mars. So Adriana, anything else before we move on?
Yeah. CJ Midwest asks, from what I can tell, we are watching Mars via Drew's camera. Is the sky clear enough to use Adler Planetarium's telescope to view more detail of the surface of Mars?
That would be possible. Although, Drew, remind me what size telescope you have?
I think my sound's back on. Yes, this is a 16-inch diameter reflecting
16 inch.
telescope.
Okay. So the Adler has a 24-inch. And the main problem, the reason that there's 2 reasons why we're not there using it. And number 1 is the museum is closed to the public right now. So getting down there is a little more difficult. We have to go through a few more hoops to be able to do it. But more importantly, right now for opposition, if Drew's telescope, if the Naperville Astronomical Association's telescope is showing Mars this murky, it's going to be even worse for ours because our telescope is even bigger, and you're going to even magnify some of that murkiness. So once it gets up higher in the sky, then we can show Mars a little better. I do have some images that other people have taken of Mars on prior evenings. So why don't we show those? So Drew, if you could stop sharing your screen. There we go. And let me show some of these cool images of Mars. So give me just a second, and then Frank, we will come to you. So let me find these. There we go. All right. So this is an image of Mars that Ron Masters took on October 5th, so about a week ago. So you can see he's got some of those same surface features. He's got a hint of a polar cap here, and he kindly provided all the details related to the telescope and the camera and his whole setup. So that's what the rest of the information is here. If you miss it, just rewind the video. You'll be able to really study this information. So it'll be there for you. But we do have some more images. This one was taken by Joe Guzman, our good friend and buddy, the Chicago astronomer. He got Mars also on October 5th. And you can see even more surface detail and definitely a polar cap, the southern polar cap there. And this is courtesy of Michael Borland, also a Naperville Astronomical Association member, I believe. He's got a beautiful image of Mars taken a week ago. So on the day of our last Sky Observers Hangout show, that was when Mars was closest to Earth. And you can see even more of that surface detail. Pretty cool. And again, if you want to check out the bit.ly link that's in here, just type that in after we're done. Just go back and grab that bit.ly link and you can see even more of Michael's images. This was taken by our buddy Nick, our pal. When he was taking a picture of Mars, you can see Mars over the house right here and a plane, I believe, taking off from Midway. So he wanted to show you what Mars looks like in the actual sky. So while we were doing the show, or a little after, he was taking this picture, which I think was really cool. And our friend Karen also got this picture of Mars with her phone outside while we were doing the Sky Observers Hangout show last week as well. So thank you, Karen, for doing that. This is courtesy of Michael. We've got Mars on October 7th. So Michael did a fabulous job with his images. And you can see that we've got more detail in these pictures. These are quite a few images stacked together. So this isn't one snap, except for Joe Guzman's picture. That was one snap. The rest of these are lots of individual images all stacked together. So Nick took this picture a few days ago. Beautiful image when the seeing calmed down finally quite a bit. And this one, Jose Morales, Adler Telescope volunteer extraordinaire and sky photographer, took just a beautiful image of Mars. I think Jose gets my vote for the favorite one. Yeah, this is really, really cool. One. Yeah, but again, it's not going to look like this through the telescope. This is the result of lots of individual quick images of Mars all stacked together to bring out all that detail. All right, there we go. There's our images of Mars, but we can do even better than Mars. Not only Mars. I'd like to reintroduce Frank Klickar, Commander Frank Klickar, and welcome, Frank. How you doing?
Real good.
And happy birthday to the United States Navy, number 245. That is impressive. Absolutely. So, but we're not just bringing that up for
that's right.
For any old reason. There's a good reason why we're connecting this to Mars. Do you want to tell our folks about that?
Yes, well, the Navy has a connection to Mars, which most people don't realize. Back in 1877, Asaph Hall, who was the director of the Naval Observatory in Washington, D.C., which, by the way, is also the home of the Vice President of the United States. He lives at the Naval Observatory. But he was looking for moons of Mars. He thought Mars might have a moon or two. Well, in August of 1877, he did discover two moons. They were named Phobos and Deimos, fear and panic, which is rather appropriate considering Mars is, of course, the god of war. And he used the 26-inch telescope there at the Naval Observatory, which at the time was one of the largest telescopes in the world. Now, what he discovered were these little tiny moons. One is only about 18 miles across, and one's about 8 miles across. We think they're probably captured asteroids, but they're going to have two totally different fates. One of the largest of the two, Phobos, is eventually going to either crash into Mars or be ripped apart at a certain point, and it'll form a ring around Mars, almost like Saturn. Deimos, though, is going to slowly spiral away from Mars and head out into who knows where. But people ask, well, why would the Navy be involved in this? Well, the navies of the world, this goes back a couple of hundred years, were involved in one very important function: to determine what time it was. The only way you could tell time back in the days before they had fancy computers and GPS and what have you was to look at the sky. And they knew the stars rotated. Well, they appeared to rotate as the Earth rotated every 24 hours, actually 23 hours and 56 minutes, but we won't go there. But that's the way they told time. And so the Navy had to know what time it was, because in those days, that was the way you determined your longitude. It was easy enough to determine where you were north and south, but east and west was a big problem. So most of the nations of the world who were military naval powers, like England, United States, France, all had observatories run by their Navy.
Yep, that's cool. And side note, even the Vatican has an observatory, actually
That's
two,
right.
because you want to determine exact timings for feast days and holy days and that sort of thing. So, so it is not uncommon to have different organizations, different groups of folks who you might not think have observatories. They definitely have them. But speaking of observatory, you've got Megamark Observatory, your own observatory, and so you are going to show our viewers something not Mars this evening. So would you
No,
like
there are
to?
two other planets, as you
Yeah.
mentioned earlier, and they're getting pretty low in the south now. So the seeing, like Mars, is not all that great. But I will flip to one of them, and there we are. You can barely make out that that is actually the planet Jupiter. If you look
And what Frank,
very,
what Adriana and I are going to do real briefly is we're going to stop our videos just to make your video a little bigger. So we're still here.
Great.
I
We're
can
we're
zoom it a
just gonna
bit,
stop
but
our
okay.
videos just to show that. So all right, go ahead.
Go.
Okay, go for it.
You can barely see there are two faint stripes running diagonally from basically upper left to lower right on Jupiter. Those are jet streams in the upper atmosphere of the planet. They're called the north and south equatorial belts on Jupiter. But basically, that's the weather on Jupiter. Jupiter has quite a few belts. You can't see them all here tonight. But we were talking about the moons of Mars. And Jupiter was the first planet to have other moons other than the moon of Earth, our own moon, discovered. And these are discovered by Galileo back in 1610. Now, what I'm going to do, I'm going to increase the exposure of the camera, and Jupiter is going to be very overexposed, but you will see the moons, hopefully, if it's getting a little cloudy here. So we're going to try getting the moons of Jupiter. Let's see, let's try medium. There they
There
are.
we go.
Oh, there they go.
We got them.
And I believe we have what?
We have,
Europa?
yep, to the left, we have Io or Io, however you want to pronounce it. To the right, just to the right of Jupiter there, to the lower right is Europa. And to the farther lower right is Ganymede.
Now there's one other missing, and that's Callisto, and that I think is off the edge of the field, so we
I
can't.
believe so. I'm checking. I think it's up to the upper left. I'm just checking on that.
I can zoom out,
Yes.
but I
Yes, it is
probably
up
won't.
to the far upper left, off the frame of the.
Yeah, it's off the
picture.
frame. Okay, no problem.
That's okay.
Well,
Pretty cool.
There's one other thing we can look at tonight too. I'm going to go back to the standard exposure here on Jupiter. There we go. And it, again, it's pretty fuzzy. This next object is the thing that most people, when they come to my observatory, say, can you show us a certain thing? And I say, well, if it's up, I'll be happy to. And I'm going to show you that wonderful thing right now. It's getting sort of low. We'll hope it's visible. Now I'm going to leave the telescope camera on the screen. Jupiter will suddenly disappear, and if we're lucky, something else will appear instead. Bye-bye, Jupiter. And hello, Saturn.
Yay.
Ooh.
Well, they're very close to each other in the sky, only a few degrees apart. And it's a little higher in the sky, so the seeing is slightly better, but you can definitely see Saturn has a ring. I'll blow it up a little bit. That's about all you want to do. In fact, by enlarging it shows something that most people don't realize when they look at objects through a telescope. High magnification isn't always what you want. You will often see more at a lower magnification. It depends on the telescope, but even with the telescope that we have here or the telescope that Drew is using at our club observatory, rarely do we go over 200 power. You will see, telescopes advertise, oh, this is 600 power, 800 power. Well, maybe, but I'll tell you now, if you look at Jupiter or Saturn through one of those telescopes at that magnification, you couldn't tell if you were looking at a planet or a street light because all you'd see would be a big blob. But Saturn has some moons too. I don't think, though, with the haze we have tonight that I can bring them out. I'll give it a try. We'll see what happens. Yes, there's
there
one.
it is.
Oh, cool.
That's,
Oh, wait.
that's in fact, there's two. There's one
two.
here too.
Yeah. So I'm going to check to see which ones we have.
I'll try medium and see if that's, a little better. There we go. I'm guessing the bright one, being it's so bright, it could be Titan.
Yep, that is Titan. And the one to the upper left there, I think is Rhea. I think. And
the interesting thing about Titan, of course, is that we have landed a space probe on that little moon. The Cassini mission went to Saturn more than a decade ago, and the Huygens probe, built by the European Space Agency, was detached from Cassini and parachuted down to the surface of that little moon. Well, it's not so little, it's one of the biggest moons in the solar system, almost as big as ours, as I recall. And it discovered an amazingly Earth-like look to it. Not that it was like Earth as from the standpoint of atmosphere, but it had lakes and mountains. The thing was, the lakes were made of liquid hydrocarbons, methane, the same gas you use to cook on your stove. That gas was condensed into a liquid and formed lakes on the surface of Titan. So there's a place where we have been. We can't land on Saturn, of course, for the simple reason that Saturn, like Jupiter, doesn't have a solid surface. Right. And our astronomer there can probably give you more details of exactly what Saturn and Jupiter are made of.
Right. I'm going to turn my video back on here. Give me just a second. There we go. Cool. That is really awesome. Yeah, it's one thing that that you mentioned, Frank, that it's definitely not important sometimes to go high on your magnification. Telescopes are made to collect light first and foremost. So the bigger the telescope, the brighter the object. Second, what telescopes do is resolution, so seeing detail. And way down on the list is magnifying. So we want to see dim stuff, and we want to see detail on that dim stuff. And we kind of don't care so much about magnification. So that's why we don't try to crank up the magnification on everything that we see. So still, you got to admit, for the haziness that we have tonight with the thin clouds, it still looks pretty good.
Not a bad image tonight.
Not a bad image. So I'm gonna give Drew a heads up. Drew, how's it looking over in your direction? Any better with Mars, or did we
get
cloud
my sound
out?
back on here?
Yep, sure is.
It's had its moments of, I guess if we're clear, let me get it back to the center here. So that dark banding there is holding a little more steady on it.
Yep.
Now as it's getting higher in the sky, but we're still doing a lot of swimming around here. Then I was tossed. I was watching it a minute ago, and it's having a toss-up. So you noticed on the photographs that were taken in the last couple of weeks that the ice cap, the polar cap that we're seeing, it's actually, if I'm not mistaken, it's the southern one, is actually gotten pretty small. It's tilted toward the sun. The polar caps grow and shrink as they tilt toward and away from the sun. And just because the sun is coming more overhead or less. And so it's not a very big dot. It usually stands out there are times when you can see them both at the same time, the north and the south, when they're both big, which happens some years. But right now it's pretty small. It does stand out on a sharp night because it's white and everything else is more of a rusty color of the planet. And I thought when I put the camera in and I was rotating, I thought I saw it up there. Now I'm thinking it's right down here at 7 o'clock. But let me adjust the exposure again. Again, it's really tiny. And at this magnification, it's not going to, it doesn't like take up 20% of the surface. It takes up like 3% of the surface, I think. So it's pretty subtle. But again, that somewhat diagonal stripe of that, the darker marking on the planet, again, the difference between the lighter and darker parts is subtle in any case. The photographs accentuate it, they kind of artificially accentuate it. So again, this is what it looks like to your eye, but the darker areas are more bare rock on the surface of the planet. The rustier areas are more rubble and sand that has weathered and has that rustier color to it. So that's what you're seeing there on the planet. Again, it would probably look better in a few hours, although we have a moderate cloud cover here now we're looking through. So I'm not sure what that'll do the rest of the night.
Well, you got to admit, it looks, I think it looks even a little better than it did last week. So we're seeing a little more detail this week than we did last week. Adriana, do we have any questions from folks? I know Lucy Ann is probably holding the fort down really well with those questions. So how are we doing?
Yeah, Lucy Ann's doing a great job. I do have one question that maybe we could elaborate on. We got a question from Christopher Rose asking which telescope is showing this. Drew and Frank, do you guys want to give maybe a quick description of each of the telescopes?
Sure. I'll start it here since you're looking at Mars through this telescope. I know it's not very bright in the observatory. Just a second, I'm going to climb down the ladder. I've been standing on a ladder all evening. I'm going to climb down the ladder and turn on a light. I don't think this will ruin the imaging terribly if I turn on a little bit of light in here. That probably just got a lot brighter. Or maybe it didn't. Because the trouble is the telescope is black here. But so this telescope we're looking through here is what's called a reflecting telescope. It uses a mirror to gather and focus the light. This design of telescope was actually conceived by a guy named Newton, Isaac Newton. And so it's been around for a while. We still call it a Newtonian reflecting telescope. He was making his mirrors out of metal, actually, out of a poured metal alloy. We use glass, which is much more stable to work with, and we have a silver coating on it. So there's a parabolic mirror down at the end that's gathering the light and focusing it for us. It does the brunt of the work of the telescope. And this telescope is 16 inches in diameter, so it's basically like we have a funnel that's 16 inches across, and all of the light from a target like Mars falls into that funnel, and the telescope very capably focuses that light into a nice sharp image up at the front end of the telescope. Normally we put an eyepiece there to look at with our eyes. Oh, Mars has disappeared.
Yep. I'm gonna stop your screen sharing, but we can still see you. So go ahead.
Okay. Anyway, so this telescope is actually built for doing visual work in. We have another observatory with a similar fairly large telescope in it that we use for video work like this, but it can't see as far down in the sky as Mars is right now. So we switched over to our visual observatory tonight to do this. But 16-inch Newtonian reflector telescope. The camera that I've got in it in place of an eyepiece is just a closed circuit TV camera, basically. It's not going through a computer. It's not being processed at all. It's just like turning the telescope into a big TV camera lens. So that's why I can say we're not changing the color of it, because I've got the white balance neutraled out on the camera. I can change the exposure a lot on it to get the different brightnesses of planets, or to make up for when there's some clouds or less. Yeah, we've got a band. We've got quite a bit of bands of cirrus haze going across now. So I hope that answered the questions about the telescope, though.
Sure did. Thanks. And Frank, you want to tell folks about the telescope that you're using?
Yes, well, my telescope, and I can show you a picture here momentarily, is designed primarily for imaging. It's a smaller telescope than we have at the Club Observatory. It's a 10-inch or 25-centimeter Ritchie-Chrétien astrograph. It's designed primarily for taking pictures, as is the other telescope. In fact, there are 3 telescopes mounted on the mounting here. And you will see all the cameras attached, all of which are specifically designed to take pictures for astronomical purposes. And I am using a camera today, made in England, in fact, which is actually a video camera designed for astronomical work. But you do have to put it through a computer, and that's the one that we're using to look at Saturn here right now. So all of my telescopes are designed for taking pictures. The telescope at our Club Observatory, with the exception of the one smaller scope for video, the big scope is mainly designed for viewing with an eyepiece.
Cool. And at the Adler Planetarium, we have a 24-inch corrected Dahl-Kirkham plane wave telescope. Basically, it's a bigger telescope than the one we had, and we've just started using it very, very recently, as actually last night. So we hope to feature that telescope in a future Sky Observers Hangout. So we hope you'll join us for a future show and maybe see us doing something live or recorded, either one, from that particular telescope. So we hope to show that off. But in the meantime, we wanted to really feature our friends out in the local astronomy community. And we just cannot thank them enough. The Naperville Astronomical Association, who does also does their own online programs. And so, Drew, do you want to take a minute and just tell folks about any upcoming online programs you guys have going on?
Sure. Well, we're actually in the process of, we're going to transfer a lot of the things we've done over to YouTube also, but we have a Facebook presence, and we also show our things off of our club website. So in either case, if you just search on your favorite search engine for Naperville and astronomy, will come up. But we do two indoor programs a month. We've transferred to being online. We have a regular meeting program, and then our fundamentals program. And then our observing things we do whenever we get a chance to. So it's very weather dependent, and we generally will announce them on Facebook a day or two in advance, because that's when we're pretty certain we're going to have a clear night for them. But yeah, we're doing as much as we can. So,
wonderful. Well, it's so great to have you guys here. And Frank, would you like to say anything about the club or your work with your telescope? Any cool stuff? Any words of wisdom for the audience out there who might be thinking, "Hey, I want to do some of this stuff." Anything you'd like to say to anybody out there in the audience?
Yes. Well, one thing is, consider joining our club. Obviously, we don't have live meetings this year because of our pandemic, but we'll certainly hope to have them next year. But we do have regular meetings once a month at the Naperville City Hall, actually. And the observatory itself that you saw Drew operating is open to the public. We will be having, hopefully, if everything goes well, we'll be hopefully having live programs there, inviting the public to physically look through the telescope. And despite all the very high-tech stuff that Drew and I have been doing this evening, there's nothing like looking through the eyepiece and seeing it live. Electronics are great, but seeing it live and seeing those photons that have been traveling, in the case of a galaxy or something, billions of years, and finally they hit your eye and no one else's.
That's
It's
right.
sort of mind-boggling.
It is. It is. It brings you closer to the rest of the universe at that point. So, Drew, anything else you'd like to say to our audience before we end for tonight?
You know, we're happy to be on the Adler team, and we're all in the same game of trying to encourage everybody out there, all of you, to look up more and remember that it's not a painted on ceiling up over us. That's the opening to the whole rest of the universe out there. And you should spend a little bit more time thinking about it and a lot more time looking up at it.
There you go.
That's what we're trying to encourage.
That is definitely a words of wisdom to follow. And for our next Sky Observers Hangout program, we are going to be concentrating on binoculars, books, and sky apps that for your phone that may get you to get out a little more and actually enjoy the sky. One of the great things about observing the sky is you can just go outside by yourself and do it. Just go outside in your backyard. There you go. Go outside to a local park. Just enjoy the sky that is above your head. And this whole program is all about trying to teach people to connect to the sky. Adriana, are there any last minute questions, comments, concerns from our audience before we wrap up for tonight?
I think Lucianne has us covered with answering these questions. So thank you very much.
Thank you so much, everybody.
And thank you, Drew and Frank, for being here tonight. It's been cool to look through those telescopes.
Yeah. And please check out the astronomy clubs in your area. Wherever you are located, you probably have a club somewhere near you. And more than likely, they have figured out how to do something online. So if you're not in the Chicago area, if you're not in the Naperville area, there are many other clubs: the Chicago Astronomical Society, the Skokie Valley Astronomers, the Lake County Astronomical Society, Northwest Suburban Astronomers, the Fox Valley Astronomical Association, Naperville Astronomical Association. I probably am missing some, and I apologize to all of our club friends out there. We know you're doing great work connecting everyone to the sky. So thank you to Drew, and thank you to Frank, and thank you to everybody else out there. Hey, everybody. How did we do? We would love to get some feedback from you. Sarah is going to link a feedback survey in the chat. It's only going to take a couple of minutes at most to fill it out. If you wouldn't mind doing that, it will help us make our shows even better. And you can send us suggestions for future show topics. We have not set our calendar yet for our show topics for January through June. Bring on the topics. We would love to know what you want us to bring a show to you about. We're going to leave the chat open for a minute or so after the end of the show in just a sec, so you can access that survey. And you can also get it via a link in the program description itself. So if you miss it in the chat, don't worry, it's in the program description. It'll stay there. And Adriana, you want to tell these folks coming up when our next show is happening?
Yep, our next show is Monday, October 26th at 7 p.m. Central Time. So a little bit earlier than this one tonight. Like Michelle said, it's going to be featuring our favorite books, apps, and binoculars for viewing the night sky. If you have recommendations for any of those that you use, please let us know via our social media feeds at Adler Planet on Twitter and Instagram, Adler Planetarium on Facebook, and use the hashtag lookup. We would love to feature your recommendation in the show. And don't forget to subscribe to our YouTube channel as well.
Thank you so much for joining us tonight, everyone. Please keep looking up, and we will see you at another Sky Observers Hangout. Good night, everybody.
Good night.